Welcome to another exercise for the workbook statistics, this time focusing on the Poisson distribution. Our exercise here in this case is as follows. A train is cancelled only in very rare occasions. On average, this happens only to 3 trains during one day. This text already gives us 2 important points for the rest of the calculation. On the first part tells us we're talking about rare events. Rare events are always an indicator you have to use the Poisson distribution because it's the distribution of rare events. So this in very rare occasions, that's actually the hint telling us use Poisson distribution. Then we know happens only to 3 trains during one day. So that's the average. 3 is our average. Since we know that for the Poisson distribution, the average and the parameter lambda, which we will need later on, are identical, we know that this parameter lambda will be 3. So that's everything we can get from this text already. Then we have 3 tasks to perform here. First, calculate what is the probability that during a day exactly 1 train is cancelled. Part B, determine the probability that at a particular station during the day more than 2 trains are cancelled. And C, on how many of the 5,660 train stations in Germany during a normal day at least 1 train is cancelled. This sounds the most complex, but if we take a closer look, it's actually not this hard. But let's start working with A. As I said, we're going to use the Poisson distribution at this point. And what we want to calculate in part 1 is that exactly 1 train is cancelled. So that P of X being equal to 1. We know, as I deduced from the exercise text, the average of the cancelled trains is 3, so the parameter lambda is also 3. That's the only information we need. We have the lambda, we have the k from what we want to calculate, so we can simply use our formula for this, which is e, the Euler number, to the power of minus lambda, and then lambda to the power of k divided by k factorial. K being 1, so we put 1 here, lambda being 3, so we put 3 here and here. Insert this, calculate this expression, get a value of 0.1494 or 14.94%. So that's a chance that exactly 1 train will be cancelled. Well, that's part 1. In part 2, again we use the Poisson distribution. Here we want to know the probability that more than 2 trains are going to be cancelled. More than 2, well, this includes 3, 4, 5, 6, and a lot of other probabilities we would have to calculate. So to make our life a bit more bearable, what I'm going to do is I'm going to calculate the counter probability. So I'm not going with larger than 2, but turning this around with 1 minus, and then go smaller or equal to 2, which is actually only 0, 1, and 2. I know, again, my parameter lambda is 3, so I'm going to split this up into those 3 parts as I mentioned. Instead of smaller or equal to, I go with equal to 0, 1, and 2. That's the only 3 cases included here. This one I already know from part A. So only have to calculate this one and that one. That's what we see here. We have the 1, we have this part copied from A. Here the lambda is still 3. Actually in both cases it's still 3. Here the k is 0 and here the k is 2. This part is actually a bit easier because everything to the power of 0 becomes 1. So we have 1 up here. And 0 factorial is also 1. So we have 1 divided by 1. So we can actually omit this whole fraction here. This we have to calculate, so it's e to the power of minus 3, and then times 3 to the power of 2 divided by 2 factorial. So if you do this step by step, this part gives us 0.0498, this part gives us 0.224. Subtracting all of these parts from 1, giving us a total result of 0.5768 or 57.68%, being the chance that more than 2 trains are delayed, or at least 3 trains are delayed. Well, that's already part B. However, before I continue, let's recall that we at this point calculated the probability as well that no train is delayed, is cancelled. That being 0.0498, because this probability we're going to use again in the final part C. What we get to at this point, again, Poisson distribution, what we want to know, how many of these train stations have cancelled trains. So what is the probability of a train being cancelled? Well, it's the exact opposite of no trains being cancelled. That's why we can, instead of calculating this one, replace it with 1 minus no train being cancelled. That's what I mentioned in the last part. That's what we calculated there already. So we simply have to plug this from part B, put this here, and we can directly calculate the end result. We have the number still as 3, but we do not even need this because, as I said, this part we know from part B, where it was the 0.0498. So we get as a result of the 5,660 train stations, there will be, let's say, at least 5,378 where trains are cancelled. Well, depending on how we care with this might imply 78 or 79. So somewhere between 78, 79 trains will be cancelled. Well, that's everything there is to this exercise. So I hope you enjoyed it. I say goodbye and see you next time.